Good afternoon and welcome to this week's IGC Events webinar Focus on Geothermal, which is presented by Think Geoenergy and Enerchange. My name is Jochen Schneider, I'm the Director of Enerchange. We welcome today Gad Shoshan, the Director International Sales and Marketing at Ormat Technologies. We invited him to speak about the Turkish market and introduce the recently installed power plants. Gad Shoshan is Magister of Cognitive Psychology and holds a Master in Management. He was for 10 years in the technology unit of the Israeli army before he joined Skytex, where he was also several years as expat in Brussels. Since 1996, he worked for different technology companies before he became in 2006 Director of International Sales and Marketing at Ormat Technologies. Since 1990, he's involved in the Turkish market, at first with Skytex, working together with the leading newspapers and later with Ormat. Since 2007, he contracted in Turkey more than 40 power plants. Gad is closely involved in the business, energy and economic circles of Turkey and is the chairman of the board of Israel-Turkey Business Council. We are looking forward to today's presentation. Recent installations, implications for the future of geothermal energy in Turkey. Gad, the floor is yours.
Okay, thank you very much. Thank you for inviting me. Thank you for using it. You know, in Israel, we are 1 hour before you, so in the middle of my Schlafstunde, but it's okay. I'm very happy to talk to you and also to answer and discuss and have some discussions later. I was speaking in several of IGs in the past, and I think it's a very interesting and very important platform. And unfortunately, with the Corona situation right now, we have to do it like that. Well, maybe it's better because everybody can see the presentation. But I really hope to meet you all in face-to-face very soon, and everybody to recover and to all of us be healthy again. I will give a very short introduction to Ormat, just where we are. We are 55 years already experience in geothermal, waste heat, solar, and recently also in storage. And we are all the time looking to diversification. And the most important and interesting and unique fact about Ormat is that we are the only fully vertical integrated for the geothermal market. That means that we also buy license, drill ourselves, develop the resource, design the power plant, manufacture most of the equipment of the electric generation, design, of course, the thermodynamic cycle, build the power plant, operate it, and get revenue from the selling the electricity. We also serve third parties, and in Turkey, this is what we are doing. We are serving third parties. We do not have our own Ormat power plant. There's some pictures from the manufacturing site. I am very happy to say that I took all of them. I'm also an amateur photographer. So you can see here that the way we are building the turbines and the air coolers. The two extreme right pictures, one above the other, is our facility in Turkey, where we are actually manufacturing also turbines over there. Up to date, from 2006 to the end of 2020, we have signed 43 power plants in Turkey, 42 of them operating, one is still under construction. This means totally 80 sets of turbines. The manufacturing shop was inaugurated in 2016, and we have dedicated project management team, after sales support, and of course local made and store of spare parts for all our customers. Okay, this was a very short introduction to Ormat. I'm sure that many of you know us. Let's talk now about the geothermal market status in Turkey, of course. So if you look at the trends at the end, toward the end of 2020, what is the trend of the total geothermal market? We see that there's a global growing demand for electricity, of course, and as well also to have energy security. This is two major factors to what's going on in the world, and geothermal is a very suitable solution for baseload generation. It's a very cost-effective solution, and there's a lot of government agencies that having investment in capital and supporting mechanism for many of the developing countries. However, if you look at the 5 largest geothermal countries outside of United States, Turkey serves as a very important role over there. But if you look at the spread, the mix of the energy generation, the electrical generation, you see that Turkey still has time to reduce its coal and oil electric generation and also its natural gas, and to increase better the geothermal side. However, geothermal is a very important part of the Turkish electricity market mix, even if it's not really a major part of it. What is the status of the Turkish geothermal market as of January 2021? I split here to 2 sections. The ORC technology, where this is the technologies providers, Atlas Copco, Exergy, Ormat, Turboden, and TAS, where they supplied actually Cryostar and Atlas Copco units. How many megawatts are open under operation and how many units are under operation. And you see here, I hope you can see my mouth, you can see here the total organic ranking cycle solution in Turkey. We have totally 70 power plants that we're working in Turkey, and 1.284 megawatt of organic ranking cycle. In the steam side, we do have one very old unit, the Ansaldo one in Kızılderili, and we have 3 newer one, 2 of them with Zurlo, 1 of them with Gurish, of a steam turbine. And here actually this is turbine buy. It's not, while in ORC you are actually delivering at least partial of a design of a power plant. When you are buying a steam turbine, usually you buy the turbine and you are responsible for making the whole thermodynamic design. However, total in Turkey today, as far as geothermal, we have 1.6 gigawatt with 77 power plant, and all this was done except Ansaldo from 2006. So this is a very, very important development and significant one that puts Turkey in a very interesting place in the geothermal market. What do we see about the geothermal geological electrical production potential? I put here the 2 maps so we know where we are. On the left side, what you see are the different points of the different geothermal identified wells and resources. And on the right side are the name of the different regions. So right now, this is the Aegean, the Western Anatolian region, where we have most of the potential, but we do have potential also in Cappadocia and in the Eastern Anatolia and Kachkar area, which are known, but to date, only the Western Anatolia is developed. There are very few concessions already sold and looked at, both in Cappadocia, there are 2, 3 companies over there, and in the Eastern Anatolia and Kachkar, Zorlu has 2 concessions and maybe 1 more, but nothing was really done there. Well, in the Eastern Anatolia and Kachkar, it's very clear. This is actually almost a war game zone over here. But all the 77 power plants that we know are all coming in the Aegean and Western Anatolia part, sometime in very close proximity to each other, and we can talk about this later on. What is going on with what is the development in existing sites? Okay, what we see is we have already 14, almost 15 years of operation, or many of them are plus minus 10 years. We see that the level of NCG, the non-conventional gases, CO2, H2S, and so on, drops. This decreased the artesian pressure of the resource, and thus this increased the need for pumping. That means what we see in the last 2-3 years is a growing demand to pump wells in order to maintain electrical production. Less NCG also released to the air, and because of this, that means better air quality. It is especially important to the steam technology based, where they're using water cooling towers, which releases part of the condensate to the air, and the people not only see the white smoke, the flame, but also smell it from time to time. But because we need to add pumps, it increased the auxiliary consumption. So maybe you are maintaining the same gross production, but you have more auxiliary consumption, so the net is reduced. Which means that we need to retune the power plants to new resource characteristic. This, again, it's much easier to do it with an ORC-based technologies and with steam technology. But anyway, this is operations that we have already looking at in several cases, and I'm sure that all cases in Turkey will go through this process, because NCG in Turkey is a component that you cannot ignore. In some places it is really significant part of the steam that you are utilizing to the unit, and some places it's less, but anyway, we do not have clean steam whatsoever. Example for such cases is the Gurish Germenchik 1, Zolu Kizildure 2 and 3, and Zolu Ala Shehir 1, Maren, Irem, Sinem Deniz sites, and Turkele 1 and 2. All of them suffer from different change in their resource, and they need to be retuned, and in some of them we're already working on it. In addition to that, in some areas, permeability decreased due to overusage, and this is where we see, especially in the Ala Shehir area, where you know, it's a nickname slang between ourselves. We call it the Turkish Swiss cheese, because too many people are just drilling holes over there in the area. If you look at it just from, if you take the maps of the wells, you see that it's full of holes over there. Well, this is really because of no cooperation or regulation on well usage and proximity of sites. We identified this already 6 years at least ago, and I remember I was talking to this in several of IGC's meetings in Ankara and in Izmir. The thing is that, unfortunately, the regulator did not pay attention to the fact that you cannot make really crazy concessions of small triangle in the middle of a huge area of another person, or not limiting the drilling of the well, let's say 100 meters at least from one border to the other. What we see is cases where one's reinjection well is actually pushing the reinjection resource, the brine and the condensate, into the upflowing underground steam into the production well of another company. This already have been discussed in at least 2 court cases that I know of. And this is one thing that the Turkish market, both the regulator and the users, the owners, should really take in consideration, you know, if they want to operate for a long time. One of the reasons when I was thinking maybe it was less of a concern, or people were not really pushing too much, is because the feeding tariff and the regulation is last for 10 years. So some companies may think, okay, I don't care what happened after 10 years. But it's also contributing to depletion of resources. Okay, let's look at a case study of the EFE for understanding a good example of good implementation of a resource. Okay, I think we have somebody, I heard that somebody from Gurish is on the line also here, so he may also want to comment later on. But anyway, we have a map on the right side, map of the wells of Gurish, and we have the left side a picture at the Germenchik 1 and FS6 at night. This is the area on the northwest side of the Gurish concession. The way Gurish managed the development of the whole field is something that actually is not the only one, but it's a very, very good example. They are ensuring resource management and conservation. That means you are not over exploiting and sucking your resource too much. You are balancing it with the permeability and with the tracer test that you are doing, and keep on your hand on the pulse of the resource under you. When you do this, you have better project financing because you are building it in modular and phases, step after step, step after step. So project financing is getting much better. You have a control room, if not for all of them, but at least for conglomerated some power plants together. So that means you are saving on resources, you're having better control on the whole field. And in Germenchik 1, what we see is the first one, Germenchik 1 and Germenchik 1 and FA1 is a double flash technology. All the rest are, I'm sorry, I did not show you the site himself. I'm sorry, here it is. So Germenchik 1 and FA1 is the double flash from Mitsubishi. All the rest of them are ORC. Now, when designing the ORCs phase by phase, we really try to do it more or less same as possible. There were changes because of the resource changes. We always can take consideration of the resource, but more or less the same. In this way, you are splitting the resource and wells as needed, so you can balance your field much easier without really changing too much in the power plant. Training on operation and management maintenance is much more efficient this way. Spare part efficiency, of course, you can have more or less the same spare part for all the units. In Germenchik 1, we had a change in resource, and the impact was mainly on Germenchik 1, on the double flash. The double flash system is very sensitive to changes in the resource. You know, if you are suddenly have less enthalpy, less steam, the whole balance is going. And we see this in Germenchik, we see this also in Zorlu, in both in Alasehir and in Kizildere, that we need to retune the units, but when we are doing it with the ORC units, it's much easier to retune them. And another thing that we see with the steam turbines, there is environmental rejection due to vapor and odor from the cooling tower. It doesn't happen with the ORC solution, but there is a big notion also right now in the area of Germenchik and in some areas around Alasehir that there is an environmental lobbying against geothermal, which is really pity. People don't understand really, and they are propelled by rumors or by all kind of other very strong group of interests but we are facing it. Okay, why we didn't have any new project in 2020? First of all is the regulation. The regulatory system that EMRA put in and the other, they were changing, the energy ministry changed the department evolved within the years, but the regulation in Turkey was, as far as I saw it, for a long time, very clever. They did not promise a very high feeding tariff, but a reasonable one. But they helped a lot in all kind of other ways, in rights of the land and in all kind of grace period for taxation and so on. However, at a certain time around 2016, the regulation introduced also a need for local manufacturing for various reasons, and the feeding tariff was always marked in dollars. So what happens is at the end of 2019, the regulation expired, and there was no update or renewed of the regulation or delivering new regulation or a new update to this. There were a lot of discussions. We are already in January 21. Right now, there is some kind of an extension until the end of 21, but it's only to complete all the units that are still under development, under construction right now. And that's a real problem. Anyway, I hear a lot of talking about it. The key issue for this, as I said, the feed-in tariff was in US dollar. It was converted, of course, to Turkish lira, but on a monthly base. Whenever you were supposed to be paid, they're taking the dollar rate and convert it to Turkish lira. Mind you, when we started the geothermal regulatory law, the renewable law, which was in 2008 or 9, I think, the dollar rate to Turkish lira was 1.4 maybe. Today we're talking about 7.3. So it's a burden on the Turkish government, and it's quite understood that you have to find a mechanism of how to do it. But this new mechanism is discussed for a long time, and nobody knows what it's going to be, what kind of mixture is going to be. The local manufacturing also, Turkey wants to increase the local manufacturing part. Actually, they would like to have everything manufactured in Turkey. However, both companies like Ormat and also the EU object to this in concept, and it is dependent also in kind of financial support that Turkey gets from abroad. They said if you're doing everything locally, we will not support you. And there is also, especially as far as Ormat is concerned, there's issues of quality. Some of the raw material does not exist in Turkey. Some of the qualification of the people who's doing really like building the internal of the turbine and so on does not exist in Turkey, and so on. And another thing about the regulation, part of it was successful, but the regulation for renewable energy included all kinds of renewable energy, and right now we're talking about split. There was a first split of it about 3 years ago or 5 years ago, but we are talking about a split to various renewable technology and this is something that all of us succeeded to convince the government at least to understand that geothermal is not wind and nor photovoltaic. The whole investment is different, the whole process is different, and it's another way of doing electricity which should be treated with the regulation and with the regulator, with EMRA, differently. So this was the first halt for no contract signed in 2020. The other one, of course, is the economy. Turkish interest rate for its loan is higher than its GDP. That means that Turkey is in a deep shit, I may say. And I know the Turkish people for a long time. They will come out of it. It's a very strong, very skilled people and community. They will come out of it. But right now, for too long, the economy really stumbled. Because of this external debt, there is no local bank backup. I mean, local bank, if they want to support you, they don't have any backup for any international banks. For the last deals that we did, it was very hard to find some project financing that will be confirmed or backed up by international monetary organization. World Bank is coming and going all the time. It gives some support. EBRD gives some support, but all this is really of a problem, and part of it is, of course, results of this is also there's a very high level of unemployment that's going on, and all this means that we are stuck. During 2020, we had all the companies who are involved in Turkey in geothermal discussion with all kinds of companies, but this is all discussions on the table. I mean, it's okay. If anything happened, if we have the regulation, if the economy will pick up, we immediately can go and start to discuss of finalizing a project. But right now, nobody will take any decision on discussing the project. The only thing that was really recently is that a French company bought Gümüşköy together with Egesim, but this is not a new project. They are buying something that was for sale, and there are some other power plant, geothermal power plants that are for sale that are discussed with different people. For whatever reason, this was bought, but no new projects. Okay, what about the future? When I look at the future of the geothermal in Turkey, I see a very positive future for this. I have to assume that Turkey, based on the history that I know and based on the culture of the people that I know, will come out of its economical problem. We also have to hope that the corona will disappear, or at least will be allow us to go to some kind of normal way of life again. But Corona did not stop the projects of geothermal. So in addition to Western Anatolia and the region, Cappadocia and Eastern Anatolia and South Kachkar is known areas that can be developed. There is a geological reason why there should be geothermal heat over there. In Cappadocia, the question is, do we have enough water to observe this heat to create project over there? But definitely in Eastern Anatolia, in different places, Mush, Van, and so on, Nemrut, we know that there is an existing potential. Everybody hopes also that the Syria-Iraqi warfare will slowly disappear and we'll be able to be safe there and to do development over there. And South Kachkar also very close to Armenia. Also in Armenia, we know there is a geothermal potential, but also over there, it's a little bit of a tension area. But definitely, these are areas that we can grow into, everybody. I mean, I'm talking about the Turkish geothermal market. There is a growing need for electricity in Turkey. Turkey is a very industrial country, very strong on this, and this is also what will pull it out of its economical difficulties right now. But there's a growing need of electricity, and there is a high dependence on external energy, which is imported, and it drives the need for local production. All the gas actually in Turkey is imported, and this dependence is not at all favored by the Turkish government now, or even in the past, but now it's very obvious. You almost say it verbally. The interesting about the Turkish geothermal sector, this is driven mainly by the private sector. And by that, it keeps focus on the business models. That means I hardly saw a real strong political intervention in this. The politicians, they have their own way of interfering there, but they said, okay, guys, develop it and do it, and it's a private sector investment. The government money is somehow there, but it's not a major factor over there. So when we are talking about developers in Turkey, the business model is what influences what you are doing. And the fact that we have a very positive past history encourage both foreign investor as well as local investor to continue and invest in geothermal. I'm sure also that photovoltaic will be a big investment as soon as the economical situation starts to flare again. But as far as geothermal, this is where I see it. I hope I kind of cleared everything, and I think we can open now for question and answers.
Thank you very much, Gad. This was very interesting to get an overview from you. I also want to welcome here Cannur Bozkurt, who is the editor of Jeothermalhaberler. Hello, Cannur, do you hear us?
Yes, good afternoon to everybody, also to the audience. Thank you very much, Gadi. Definitely, this was a very brief and informative picture of Turkey, especially referring to the lack of a responsive regulation. Yeah, maybe we have a regulation which is nice, but needs to be improved. And I think we need to have it from a power generation dominated version to let us use the geothermal resources also for direct uses, because most probably this is the only way to convince the public that this is a definitely green and sustainable resource for future. I would like to ask you that yesterday I was moderating a session in Turkish Energy Forum, and one of the panelists was from World Bank, and she stated that they would like to also support direct use applications, but also cascade systems. Because if you can have a cascade system, especially with the current installed capacity, we can go to a carbon neutral future more fast in Turkey, let's say. So is the technology of your power plants allow this? And the reason I'm asking is some of the operators and investors I had the discussion in Turkey mentioned that they didn't consider in the first phase of the design, and they need to make some investments to upgrade their plants to support any integrated applications.
Just to make sure I understand, when you are talking about cascade system, you mean like a multi-application, so the same resource used for different application?
Yes.
Okay, well, first of all, yes, it's because we are designing the power plant totally ourselves, so it's much more efficient to know if you have any ideas of utilizing the resource for others application when you are designing it. It will be much better than to do it after the unit is installed. Indeed, you will have to do some investment if you want to change it later on. But we are very much familiar with multi-application users of a geothermal resource, also in Turkey. For example, Kızılderili 1 and Dora 1 and 2 are extracting the CO2 into facilities that create CO2 for Coca-Cola. So of course, when you are drinking Coca-Cola in Turkey, it has a little bit taste of H2S, but you don't feel it with all the other acids they put there. But also in Dora 2, they are using the heat that is left over on the brine and the condensate to heat the greenhouses. They have a beautiful tomato greenhouse that is in collaboration with some Dutch company. And they're also using some of the CO2 also to feed the tomatoes over there. So this multiple application is very much recommended. The most beautiful case that we have in Ormat is the Bad Blumau of the Rogner company in Austria, where they have one well that produces heat for a 250 kilowatt unit of Ormat. We designed it in a way that it's taking the brine out at 90 degrees and it's going to district heating of the whole resource. It's a spa, it's a very luxurious spa area in Austria. This going out of the district heating of the spa at about 40 degrees, going into the different pools of the spa, and then everything is reinjected at about 20 degrees. So this is the most efficient and most beautiful case of to see how you can actually utilize the resource. You can also use it for food drying. You can use it for cooling. You know, there is the ORC leaves heat out. You can design if you want to take the brine and the condensate at 90 degrees, at 80 degrees, at 70, at 60 degrees. You will have more electricity, less electricity, but definitely you can do a combined application. And actually, this is, whenever I talk to people, I encourage it very much. I think it's a very beautiful way to show that you are utilizing the resource and you are reinjecting everything, of course, back, which is also beautiful.
Okay, thank you. Thank you, Cannur, also for your question. You want to mention anything else?
Yeah, I would like to add something, in fact. Based on the discussions I performed with the operators, I would like to hear from Gadi, based on his experience. Do you think for the current power plants, to update them in a way that they can also provide these cascade or integrated applications, would it create a financial burden?
No, well, you will. We will have to go case by case and to see what are the needs and what is the temperature that is left out. So we'll have to go per the base by base. But if you look, for example, the Bereket power plant near Kızılderili in that is delivering district heating to Sarakoy, they have to invest on the district heating exchange shade or whatever equipment that they need to have. You will need to, of course, invest on the applications that you want to use it for. But case by case, in many cases, you will just need to take the outcome that's coming out of the power plant, and instead of reinjecting it the way it is, go to another application, use it, and then reinject it. So there will be an investment, of course, in building a district heating exchange facility, or building pipelines for CO2, for a CO2 manufacturing for greenhouses or heating greenhouses and so on. But in most cases, the power plant itself should not be affected, and there shouldn't be any real change in the power plant itself.
Thank you very much for the clarification. I mean, the benefit versus the, let's say, considerable investment required. I think definitely this would be an option for the Turkish market. Thank you again.
Okay, then we head on to some questions by the audience. One question: why does Turkey apply binary cycle systems rather than condensing systems?
Okay, well, it boils down to the fact that the resource that we have is not something that we can order. We are drilling, and whatever Mother Nature gives us, this is what we have to utilize. Now, there are two parts of my answer. First of all, the Turkish specifically. When you're talking about steam turbine and what you call condensing application or technology, it has some advantage and some disadvantage. The fact that all Turkish resources has relatively high level of NCG, which calls for all kind of additional pumping when you're talking about a steam-based solution, and it's a big disadvantage. Just to give you for an example, in the Germenchik 1 unit that is a double flash, which is 47.5 megawatt gross, I will say, as far as I know, about 6 megawatt goes into pumping and into all these kind of things that has to be taken care in order for the steam solution to work properly, which we don't have at all when we are using ORC. So the Turkish resource is not suitable for steam. Now, I will even enlarge it a little bit bigger, because right now, I will be a little bit more careful. I said the cases where steam, geothermal steam, is used is in favor for geothermal electric production is very rare, because the steam has to be clean, and it has to you have to see what you're doing with the leftover brine and with the fact that it's getting more condensed. And as far as we know today, there are only two places where you have nice steam, if we may say, that you can do it. It is Iceland and New Zealand. Nevertheless, if you look at the Tamariki case in New Zealand, that Ormat installed their 100 megawatt for a contract energy, I think, they have a lot of steam, but in order to reinject everything and in order to maintain the resource well for a long time, they understand that they have to reinject everything. When you're using steam technology, you are taking some of the resource all the time out. And you know, the case of the geysers in USA is well known, where suddenly you are deploying you have a depletion of your resource tremendously. So Turkey's resource is suitable for ORC. I will say I will be very fierce on that. All the one who has steam solutions there, the three units that we see, are not as successful as it would have been if it would have used ORC.
Okay, thank you. Here we have another question. You have something to mention, Cannur?
Yeah, excuse me. I just would kind of like to ask Gad if he can clarify that, because one of the crisis created from the social acceptance point of view is within this technology, the water steam coming out of the, let's say, cooling towers or something like that, which is affecting the surrounding environment. So can he just a bit clarify this, especially for the Turkish resources?
Well, the pictures that you see in front of you is 3 power plants. They are under operation right now. Nothing comes out. You don't see anything. It is not the models, it's nothing. These are operating power plants. When you're using ORC and you're using air cooling system, nothing is released out, nothing. Only there's noisy, but not even too much noise. When you have a cooling tower for the steam, you are using the condensate of the steam in order to do a makeup water for the cooling tower. Now, this condensate of the steam includes also particle of H2S and of course CO2 and so whatever you couldn't release in the NCG. And when you're putting it in the cooling tower, not only you have the plum of the white smoke coming out that people don't like, but frankly, this is just vapors, but still it has a problem. I'll talk about it in a moment. But also those particles of H2S make it smelly. Now, not only smelly, we had a case in New Zealand and we had a case in Aden area where this is the heaven of fig growing worldwide. I think the best figs ever, Injir. If you are releasing the vapors with the cooling tower to the air, it is somewhere starting to be condensate into water again, and it is dripping on the trees around it. In New Zealand, it happened with vines, where they used to do wineries, and in the Aden area, it was on the fig trees. And if you have a little bit of H2S with this, also it makes holes on it. So there is an effect on the agriculture around it when you're using cooling towers that are utilizing makeup water of geothermal condensate. And this is not nice. Let's put it this way.
Yeah, thank you very much.
Okay, do geothermal operators typically monitor induced seismicity is one question, and I also want to mention another. Are there any problems with seismicity in Turkish geothermal projects?
Well, the best case that we have about seismic issues is, of course, Puna in Hawaii, where there was the eruption of the lava a couple of years ago, and only in a couple of months we put again the Ormat Puna power plant back to work. But let's put it this way, our control system are all designed to identify seismic eruptions and seismic activities, and you can set the level at what times they will stop everything and close all the valves in order to avoid any disaster. However, until today, we had no problem whatsoever with seismic activity in none of our power plant. Of course, naturally, geothermal does not cause seismic activities, but naturally, where you have resources that are suitable for geothermal, those are also areas where you have more seismic activity. As I said, until today, we never had any problem with this.
Jana, you want to mention anything to this topic?
In fact, no, because this is very sensitive for Turkey. Yeah, but I just would like to mention that in the final cumulative impact assessment report prepared for the ministry and funded by EBRD, it was one of the suggestions to be added into the regulation that this needs to be monitored. And with this, I mean the reinjection brine. If the reinjection brine creates any minor seismicity around the power plants.
We have more than 150 cases around the world where the injection of the brine didn't do anything. And as I said, all of them are in a seismic sensitivity. But as I said, we have sensors. It's part of our control philosophy. We have sensors that are sensing the seismic activity, and we have mechanisms and way of controlling it and ensuring that in case something happened like earthquake and so on, there will be limited to no effect on the power plant. Of course, if there is a tremendous earthquake, you will maybe have to repair things, you will have to fix things. But we didn't have any case, any problem until today with these cases.
Yeah, exactly. This was the base for the monitoring, because also for Turkey, it is to relieve the people, to communities. It is always better to talk with data, which we don't have now in general. That's all for me for this topic.
Okay, we move on to the next question. Hi, Gad. Thank you very much for the presentation. In your experience, what is the minimum required flow rate for economically developing a geothermal power plant?
Okay, it's a very common
Perhaps we can
question.
also add the temperature, the minimum temperature.
Yes, of course. One factor is the ambient temperature for the air cooling. So in Alaska, for example, we have a power plant, a very small one that is working with a temperature of, I think it is 85 degrees, but of course the average ambient temperature out there is between 4 to 0. But nevertheless, what I'm saying whenever I've been asked this is 100 degrees, 110 degrees of resource and 100 tons per hour will put you into a about 250 kilowatt unit, which is the beginning to start with. It also will not be very cheap, but this is to start with. However, as far as the technology goes, we already did a project with much less temperature. As I said, in Alaska and in Antarctica, there's also a very small unit of us generating electricity, not from geothermal, but very efficient because of the cold air over there. So this is my rule of thumb: is 100 tons per hour with 110 degrees of resource.
Okay, thank you very much. The next question is: power grid infrastructure an important limiter on plant feasibility in Turkey, or is the grid less of a problem?
It is a problem. It is a problem because you have to see where you are, because we cannot select where we are putting the power plant. When we started with Dora 1, was the first geothermal ORC power plant in Turkey, the grid there for a long time was very, very unstable. And sometimes they had 2 or 3 shutdowns because of grid failures in the area. By the way, this is exactly why storage becoming an issue on the electric market. Storage the solutions, part of it is to avoid instability of the grid. In some of our power plant, both Ormat around the world and also in Turkey, the investor had to build connection to the grid lines of several kilometers. It's not very cheap. But the Turkey made a tremendous advance in the last 15 years with the spread of the high voltage grids in the areas where you have a lot of geothermal power plants. So, for example, all the way from Izmir to Aydın and almost to Gümüşköy, there is a new high voltage grid that supports the power plants over there very nicely. And also in the Alasehir areas, they're taking care of it. So it's an issue, definitely, but it's not a grave issue. It's the Turkish government really takes good care on this side.
Okay, thanks. The next question is: what is your view on the relative lack of geothermal development in South America? Is there a scope for an Ormat-Turkish collaboration?
Oh, South America. Well, first of all, thank you. I'm not I'm not involved in South America into details. It's too far for me to fly over there. But South America has a geothermal potential. I think the regulation was for a long time unstable there. The political risk was relatively high. Anyway, we do have some very interesting power plants in South America. The last one in Chile is about 4 kilometers height on the mountain, and we had to put I think over 25 kilometers of grid line to connect it to the first substation. We are doing all kind of collaboration over there. If anybody has an idea of he wants to get collaboration on South America project with Ormat, all what I can do is I can introduce him to the guys who's doing business development in South America.
Okay, thanks. Now we have another question to the subsurface. How significant are your corrosion problems? And do you apply chrome tubulars or GRE-lined steel or other solutions?
I don't know. Unfortunately, I'm sorry. I'm stepping into an area which I cannot add anything.
It's okay. You mentioned reinjection beneath 60 degrees Celsius. Is this possible in all Turkish geothermal areas, or are there problems with precipitations in the wells at low temperatures?
It's a question for each site by itself. Some of the places where you have higher silica factor, it will be a problem, which sometimes you can use it. You can handle it with a chemical treatment, and sometimes you can do it. It's really there is difference in the chemical analysis of the resources along the Menderes. Also, there's changes, and of course in the Ala Sehir Manisar Graben also. So you have to consider each case by itself, and of course the reinjection temperatures that we select with the developer when we're working on designing the power plant, of course take in consideration the chemical analysis and what can be done. And so it's case by case.
Thanks. The next question is regarding the increasing cooling demand in the future. Do you also consider cooling supply by means of geothermal heat using absorption chiller or using geothermal electricity for chillers? Do you have some specific cases in mind?
I don't have any specific case in mind right now, but I know that there are areas where geothermal heat is used for cooling chillers, and it's possible. Now the question is, again, we have to look case by case to see what is the temperature that is required, and does the brine support it, and how cool we can go down with providing a chiller solution for this. Again, case by case, but it's definitely possible.
Thank you. How will climate change impact geothermal plants? Do you know any study on this issue?
No, I don't know any study on this issue. The climate change is affecting more of the air temperature as far as we are considered. So if the winter is going to be colder and the summer will be hotter, then of course the efficiency of the air cooling system will be affected accordingly. And the only way I can see that we are all the time working into trying to improve the efficiency of the air coolers in various ways, and probably we will need to also add in the future more air cooling bays in order to support the ambient temperature changes. What is the effect of the climate change on the resource under? I don't know of any studies that was looking into it, and I don't know.
There are two more questions, and then I also have one. Perhaps Shano also have another one. Thank you for a great talk. Similarly, is water resource access an important constraint?
Water resource for water cooling? Or as we are using air cooling, we don't have any issue with water resources. We are using geothermal water, which are drilled.
Exactly. This is the only one. Yes, yeah. But there is no other water needed for a geothermal plant, just the geothermal water. So I have a question. You just showed the areas of the potential in Western Anatolia, in Cappadocia, and Eastern Anatolia.
Yes.
So how much development do you see in gigawatt? We are now at 1.6 gigawatt, as you showed before. What will be there in the future?
Oh, I don't know. I'm not such a prophet, but I will dare to say that we can at least double it.
Okay, this is nice. Yes, for doubling it, I think the expectations were once by 2 gigawatt, but doubling would be 3 gigawatt, more than 3 gigawatt.
Yes. Yes.
There are some latest studies. I think will be also published within the coming near future. That it is like 4 gigawatts for power generation.
Yes. Okay. It makes sense to me. If you look at the Kachkar, the Eastern Anatolia region, and I'm not even putting Cappadocia right now because I don't know what will be the water permeability there, but it's definitely, from geological point of view, it's a place where a lot of activity and a nice heat relatively close to the surface. But the question again is the availability of water. But knowing the Kachkar area and knowing the area over there, there shouldn't be a problem with water. So I think I will support what Cannur is saying.
Cannur, wasn't there a project in Cappadocia which found about 300 degrees Celsius
Yeah,
of
the
temperature?
highest recorded temperature, like the highest record in Turkey.
But the question, so they drilled a well, and what is going on in this project?
It's 300 degrees, but it's not 300 degrees of water.
Yes.
Slight modification.
Yeah, I mean, there are, I mean, it was just one of the wells, so the area is now under development, but as far as I know, the company has joined the RSM program of World Bank, if I'm not wrong. So they were preparing to drill a couple of more wells in the region, this risk-sharing mechanism.
Yeah,
okay.
The companies that did it was thinking of employing hot-dry rock solution. Now, all what I said about the effect of the geothermal right now, the way we do it is that we are not doing hot-dry rock. We are not re-injecting water from the surface into throwing it into rocks at 300 degrees and wishing to have some of it back at a very high temperature. I don't know what this will do, because it's a different game that you're trying to play with Mother Nature. I'm not saying it's not possible, but I'm saying right now it is all still very nice for universities and for geological institute to investigate. I don't see yet a business model that can support it properly.
Johan, if you have time, can I ask a final question?
Yes, Gadi, you have time?
I'm fine, yes.
There are also some studies, let's say innovative projects under discussion here for the sustainable agricultural system or for the food drying from the direct use applications point of view. So does Ormat have plans or already have a technology to produce power from the wellhead?
What do you mean by producing power from the wellhead?
I mean, you have just one well and let's say one re-injection well, and with these two wells you have a limited up to 1 megawatt, let's say. You have a very, very small unit, maybe something modular to generate power and use it for the food drying facility itself, for instance.
Again, each resource has its own characteristic, and we have cases where we have one well that is delivering electricity. Like I said, the Bad Blumau in Austria is one well that is giving us about 100 tons per hour, and it's going through all cycle, and it's all re-injected, and we have 250 kilowatt there. But again, every resource has to be considered by itself. We have to be analyzed and see what we can do with it. There is a trend right now, especially guys who have laid their hand on some leftover second-hand pure cycle machines from the history, and they are trying to promote such a thing that you will put such a unit on the well and you will generate electricity, and then maybe in the same time you will start already it will take time until you develop more wells, or you will use this only for a very local site nearby. Now, we are producing electricity. You can decide whatever you want to do with it. You can inject it to the grid. You can use it as an island mode for your own small facility nearby. It's not a problem, for direct use and so on. So the electricity is electricity. That's what it is. And each well has to be considered what we can do with it. Does this answer your question more or less, Cannur?
Yes, exactly. So you don't have any limitation like we don't establish power plants less than 5 megawatt is something like that. No, take each project under its own specifications.
Yeah.
Yes, I have my. Thank you.
Okay, here is another comment which came in. To be clear, the NCGs that are released in the initial flash vessel for ORC in Turkey are also released to atmosphere, not just flash plants. The cases where the NCGs can be completely re-injected are rare.
Yeah, this is almost true. When you are flashing, when you're taking the resource and you are generating steam out of it, that's when you are flashing it. It has NCGs in it, but we are not extracting the NCG. At that time, we are utilizing all the steam with the NCG into our heat exchanger, and it's all above atmospheric level, and we have the patent on our vaporizers that we can take the NCG out. We are reinjecting fully the NCG in the Puna case in Hawaii. Everything is reinjected. There's a very little amount of NCG over there. There's a big issue of reinjecting NCG, especially in the amounts that you have in Turkey. Although, as I said, because of utilization of the resources around what we have today, the NCG level is dropping. Yes, it is released out, but it's not at all in the same quantities as the ones that you're doing when you are flashing, because we are always above atmospheric level. And of course, the more pressures that you are maintaining your resource, the less NCG is released. Some cases where we are maintaining the pressures that everything stays as brine, there is no steam, there is no NCG, it is clean. So one of the ways to avoid NCG release to the air is to maintain the pressure above steam breakout. It has its own limitation, of course. And as I said again, if you have a small amount of NCG, yes, we can reinject it. We have experience with this in Hawaii.
Okay, thank you very much. Just to mention your example from Bad Blumau, which I really also like very much. There they are also extracting the CO2, and they are also selling it to coke.
No. In Bad Blumau, they are not extracting CO2. It's all remained as brine.
No, they are extracting it.
Okay.
For sure. And they perhaps there was a plan to extract it when I was working on the chemistry of Bad Blumau, but I don't know if it changed now.
Okay, then you know more than me, because whenever I looked at the studies over there
in the geothermal water there.
Yeah. Okay. Excellent. I know that this is a perfect example of a multi-application usage.
Yes, exactly. This is a very, very nice example, and they use nearly everything what they can do. Okay, then thank you very much, Gadi, for your presentation, for your answers to these many questions. Thank you very much, Cannur, for supporting us here. And I want to continue with the announcement of the next German webinar. It's a Blickpunkt Geothermie. It will take place next week at the same time, and it's about gas, which is not a bridge technology, as we call it in Germany, Brückentechnologie. Moreover, it takes a break on geothermal, that geothermal cannot develop so fast. This will be introduced by the director of the IEP Pullach plant, Helmut Mangold, and we will discuss afterwards, hopefully. So thank you very much to you all, and looking forward to see you soon here. Best regards to Turkey and to Israel and everywhere else in the world. Bye-bye.
Thank you for inviting me, Jochen. Bye-bye.
It was a pleasure. Bye-bye.
Thanks. Bye.
Bye, Cannur.
Bye.
Bye-bye.